Alright, without wasting much of our time, let us look at the first aspect of binomial theorem, which is the Pascal triangle. Now, in Pascal triangle, we are going to see how to expand some function without having to do much work. All you just need is, with the help of the Pascal triangle, you'll be able to get the necessary coefficients. Now let's look at this. We know from our knowledge of indices that when you have a function or a number raised to the power of 0, automatically your answer becomes 1. So let's say I have this x plus y in bracket to the power of 0. What I'm going to get is what? Is 1. Then in a situation where I have x plus y raised to the power of 1, definitely if I am to expand this, what am I going to get? I'm going to have x, which is the same thing as x raised to the power of 1 plus what? Y raised to the power of 1. You discover that the coefficient of y of x here is 1 and the coefficient of y here is 1. Then in a situation where you have this as well, x plus y all squared. Now if you are to expand this bracket, definitely we should be getting something like x squared plus 2xy plus what? Plus y squared. Now what do you notice? You notice that the coefficient of x squared here is 1. The coefficient of xy here will give you what? 2. And the coefficient of y square here is what? Is 1. Now, with the help of the Pascal triangle, you don't need to be doing all this before you can be able to get what? Your the necessary coefficient, and that will allow you to expand your function. Imagine a situation where we now have maybe x plus y raised to the power of what? Of 10. How do you want to start expanding? By using one bracket to multiply the other one. After that, you multiply by the top bracket, and so on and so forth. So that is where Pascal triangle will come in to help us and then make our work very, very easy. Now, this is how the Pascal triangle is. Now, from what we have done, we started with 0, then 1, then 2. Likewise, we are going to have x plus y to the power of 3, x plus y to the power of 4, x plus y to the power of 5, and so on and so forth. Now, all you just need is what? The coefficients. You just have to get the coefficient, and then your expansion becomes very, very easy. Then, with the help of Pascal triangle, this is how the expansion of this, the coefficient from the expansion of all what I have listed is going to look like. Let's start. Now, when the power is 0, we said we have 1. When the power is 1, what do we have? We have the coefficient of 1 and 1. So you have 1 and 1. Then the next one, when it is what? It is 2. The power here is 2. We have the coefficient of x squared to be 1, xy to be 2, and this to be this. Now, how do we get that? All you just need to do is, you have your 1, then add this. This one and this one will give us 2. Then at the end is 1. Because when it comes to expansion, while expanding, you always, the coefficients will start from where? From 1, and then end with what? With 1. So now, if we are to do that of x plus y raised to the power of 3 now, we are starting with 1, then 1 and 2 will give us 3, 2 and 1 will also give us 3, then we end with what? With 1. Then when we get to that of 4, we are going to have 1, 1 and 3 will give us 4, 3 and 3 will give us 6, 3 and 1 will give us 4, then we end with 1. So if you look at it, it's beginning to form what? A triangle. Now, let's do for that of 5. For 5, we are going to have 1, then 1 and 4 will give us 5, 4 and 6 will give us 10, 6 and 4 will also give us 10, 4 and 1 will also give us 5, and then the last one becomes what? Becomes 1. So this is what we call the Pascal triangle. So by the time we start using this Pascal triangle now to solve some questions, you will now understand what I am trying to tell you about. Because with this, I don't need to crack my head. I don't need to write too much. All I just know is that these are the necessary coefficients. Then another thing I'll also make us to understand before we go into using Pascal triangle to solve some question is that if you look at from this place where we have x plus y squared, what do you notice? You notice that here initially we started with what? With x taking the what? The power of 2. And then when we get to this place, to the middle term now, we discover that the power of x here is 1. Then y is being introduced into it, and the power of y here becomes what? 1. And then when we get to the third term here, we have what? Y squared. That means the power of y now increased to what? To 2. So what does it mean? It means that when expanding a function, the power of x in this aspect now, though it is not in all situations they make use of x, they can give you any other letter, maybe a and b, m and n, and so on and so forth like that. But for now, we are sticking to what? X and y. So it simply means that while you are expanding, the power of x is reducing while the power of y is increasing. But in the first stage of your expansion, it is just all about x, and x taking the what? The power that was given to you, or the degree. In some textbooks you hear degree, or the degree that was given to you in the question. Then as you move, what happens? The power of x starts reducing. So you see, it reduced from 2 to 1. Then y came in with the power of 1. And then after 1, the next is x. The power of x here is what? Is 0. But we have said it earlier that whatever function or any variable to the power of 0 is equals to 1. So that's why we didn't put the x raised to the power of 0 here. So that only what we have there is what? Is y raised to the power of 2. So, and then if you look at this triangle, you discover that 1, that is the coefficient of x. 2, what we have there is what? 2xy. And then 1, and what we have there is what? Y squared. So in our next video, we are now going to see the application of Pascal triangle and how we can use them to what? Use it to solve some questions.